Hello everyone. We are doing the question number 7 from exercise 13.2 from the chapter of surface areas and volumes for class 10. A solid consisting of a right circular cone of height 120 centimeters and radius 60 centimeters standing on a hemisphere of radius 60 centimeters is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of the water left in the cylinder if the radius of the cylinder is 60 centimeters and its height is 180 centimeters. So let us try to visualize the figure. Now this is a cylinder, right? And this cylinder contains a hemisphere, and on top of the hemisphere a cone has been placed, right? Now what are the dimensions given to us? The radius of the hemisphere is how much? This hemisphere has a radius of 60 centimeters and the cone also has the same radius of 60 centimeters. The height of the cone is 120 centimeters. What is the height of this? This is going to be how much? It is going to be 60 centimeters. This is placed upright so that its bottom touches the bottom of the cylinder. What is the height of the solid? It is 60 plus 120. And what is the height of the cylinder? It is given to me as 180 centimeters. The radius of the cylinder is also given to me as 60 centimeters. That means that this solid completely fits inside this cylinder, right? How much water will be left? Because once it's going to be put inside, the water that was already there is going to come out. Now, how much water will come out? The water that comes out will be equal to the volume of this solid. So from this volume of the cylinder, which is the amount of the water that was already there, if I subtract the volume of this solid, that is the volume of the water that is going to be displaced, that is going to overflow once this solid is put inside, I'll be getting the volume of the water left inside this cylinder. So let us try to write all what is given to us. The volume of the water left, I told you, will be equal to volume of the cylinder minus the volume of the solid. I explained it to you. Now, volume of the cylinder will be how much? It is going to be equal to pi r square h. So I need to find out the radius, which is 60. The height of the cylinder is equal to 180. I'll just write that. The radius of the cone is how much? It is 60. The height of the cone is 120. I'll write the dimensions of the cylinder also. Radius 60, height is 180. I'll write the dimensions of the hemisphere also. Radius is equal to 60 centimeters. So the volume of the solid is how much? It is equal to the volume of the hemisphere plus the volume of the cone. The volume of the cone is how much? It is equal to 1 upon 3 pi r square h, which is 1 upon 3 pi into 60 square into 120, which comes out to be 144 into 10 cube pi centimeter cube. What about the volume of the hemisphere? What is the formula? It is 2 upon 3 pi r cube. So 2 upon 3 into pi into 60 cube, which comes out to be once again 144 into 10 cube pi centimeter cube. The total volume of the solid is equal to 144 into 10 raised to the power of 3 pi centimeter cube plus 144 into 10 raised to the power of 3 pi centimeter cube, which comes out to be 288 into 10 raised to the power of 3 pi centimeter cube. Now this is the volume of the solid. Let me find out the volume of the cylinder also. What is the volume of the cylinder? It is pi r square h. So r is 60, h is 180. Once I'll put the value, I'll get pi into 60 square into 180, which is equal to 6,48,000 pi centimeter cube, or I can say it is equal to as 648 into 10 raised to the power of 3 pi centimeter cube. So from this volume 648 into 10 raised to the power of 3 pi, if I'll subtract 288 into 10 raised to the power of 3 pi, I'll be getting the volume of the water that will be left out. So that comes out to be how much? It will be equal to 360 into 10 raised to the power of 3, and the value of pi, I'll take it to be as 22 upon 7. So I'll get the answer as 1131.4 into 10 raised to the power of 3 centimeter cube. Now I'll change it into meter cube. So it comes out to be 1.131 meter cube approximately. So I hope you have followed the solution for this question. Thank you so much.